In this Swift programming language tutorial, we're going to talk about a not very much talked about topic, and it's the extended grapheme clusters. And what are they? So it's all to do with characters, okay? And it's all to do with Unicode scalars. And so what are Unicode scalars? Well, just to skip over this super fast, if you know what the ASCII table is, that's the first part of it, right? Well, ASCII table wasn't big enough for the world, right? So they had to reinvent it completely to hold all symbols and emojis and everything that we have in the world today, everything and anything that you have basically on the keyboard on your phone today to be able to send, all comes underneath the Unicode scalars. And when you come over to the likes of W3 Schools, you'll see all of the list of all of the Unicode scalars that are there, with all of their decimal formats and their hexadecimal formats and their names as well, and what they looks like. And there's, as you can see, there's lots of them, all right? There are lots of them. So this is why ASCII just didn't work out, and doing stuff with 8 bits just doesn't work out. You need a lot more bits than that. And I'm not going to get into how many bits there are, because that's a bit of a discussion that other people tend to get into. All we're going to do right now is talk about how many Unicode scalars there are in each character, and how do you work out which character, how do you work this stuff out, all right? So with that said, this is the first time I'm introducing you properly to the character, and here char1 is equal to the letter E, and we are literally just saying, hey, create a character struct, right, that is using the letter E character, and that's basically all it is doing. Now the next char1a is doing the same thing, but just in an alternative manner. So let's pop back over to here once again, and then come to the basic Latin UTF-8 ones, and scroll down to 101. And as you can see here, it is Latin small letter E, and that's exactly what we are getting here. We are saying create a Unicode scalar here and instantiate a character using the base 10 number of decimal, and that is 101, which will equate to the letter E. And if we look down the bottom, you can see that it does actually equate to letter E. If we hover over here, it equates to the letter E. The next one is using type inference and type annotation, just to say, hey, this is a letter E character. Super easy. The next one is using hexadecimal. So let's come back over to here, and we can see that it actually does have the hexadecimal value of 65. So we are creating a Unicode scalar saying with the 0x at the beginning that the value that after this is then of type hexadecimal, or is in the format of hexadecimal, and that creates basically exactly the same letter. Now char2 is creating the letter E with an accent on top of it, and we are generating a character using Unicode scalars. So this is \u is saying that the number after this is a hexadecimal, and it should be treated as a Unicode scalar. And in this sense, we need two, because one is for the letter E, as in 65 here is the hexadecimal value, and the next one is to say for the accent. And if we look on the next line, char2b, that is doing exactly the same thing. It's saying this is the visual representation of the accent by itself, and this is how we generate one. But this char2 one is saying, hey, put the two together, and it still has two Unicode scalars. All right, this is the point that we're going to get onto as we go through. So we go down now and say char2 count, and now we're going to go inside the character, and every character struct has a Unicode scalars property. And that property has also a count property, and tells you how many Unicode scalars are actually required to visually represent that character. And you can see here char2 count has two Unicode scalars for it, which is why it says it down here as well. And when I can find it, char2 counts, I couldn't find it. char2 count, there you go, is 2. All right, so it says it's taken two Unicode scalars, and by no surprise, you'll see that char2a count is 1 and char2b count is also 1 as well, because they are generated only using 1. So this is where it gets really interesting, and this is where I would listen in a little bit further. The characters can be pre-composed or decomposed. And when it's a decomposed version, that means that it's going to take its pre-composed variants, and using an algorithm, it's going to extract all of the different Unicode Unicode scalars, sorry, I don't want to say characters, that are used to make up that one character using Unicode scalars. And as you can see here, there's this symbol here, and that is created using the 3 individual graphemes. These are graphemes, just like E is a grapheme and 2 is a grapheme, but this E with an accent on it takes 2 graphemes. So these individual Unicode scalars, they represent a individual grapheme, and that's why they're called Grapheme Clusters, because this is now a cluster of graphemes, okay, that come together as a decomposed version of this one character, okay? Now, why would this be like this? Well, you need to be able to compare that. There can be times where one character looks visually like the other character, but in actual fact it's not, and it's based upon how many graphemes that one letter is built up upon and what value it has, because there are some letters in the alphabets that only require one Unicode scalar. They visually look the same, but they are actually different. They have different hexadecimal values or different decimal number values. That's why it's important to decompose the character first to all of its Unicode scalars, and from there you can test the count size of its Unicode scalars to say whether or not, 1, their length is equal, and 2, whether the values are equal to. So if we wanted to compare this decomposed character with another one, then we would expect it to both have length of 3, and for the first Unicode scalar to be 1112, second to be 1161, and the third to be 11AB. That's how you would compare it. So the order is important, and also the values are also important, and the quantity of them is important to be able to compare that the 2 characters are equivalent. Now, when this just came down to using the ASCII table, this was perfectly fine because there were only so many values there, and that was it. It was one number versus another number. That's all you had to check. So this is why it's important to understand that you need to check the ASCII, the Unicode scalars, to be able to check whether or not they are actually the same. So we can see here that pre-composed count is Unicode scalars of 1, and then decomposed Unicode scalars is then 3, because it does have 3 Unicode scalars. So this really becomes important when you look at the likes of emojis, because the emojis have like their base color, but emojis can also be manipulated to have different colors as well. This is where the likes of the Unicode scalars come apparent, because it can be that one emoji, has their Unicode scalar, but then another one could be colored in a different way or have other effects made to it, and that's why it's important to look at, are they exactly the same, and so on. So with that said, this is really a abstract quick overview into Grapheme clusters and Unicode scalars. All right, I've made a video about introducing to Unicode scalars and how to create Unicode scalars using their properties, etc., etc. But this is a deeper dive into it, and you can go a lot deeper in this as well. This goes a long way back, and there's a lot of history in this. So I would, if you are really interested in this type of stuff, I would look. But this is the most that you really need to understand, is if you know you're only working with the basic Latin characters, then you only need to check the character's length in itself or the string length. However, if you know that you've got emojis in there or other symbols in that one string, then there's ways and means of testing this, which I'll make another video about that too. With that said, if you do have any feedback, anything like that, please put it in the comment section down below. If I can make a second or additional videos about this topic based upon your feedback, I'm definitely going to do this, because I think this is worthwhile people understanding it. So feel free to critique, to enhance, to do whatever in the comment section down below, and I will join in with that conversation quite willingly. Otherwise, don't forget to like, subscribe, share, and as already said, If you want to start a conversation, let's do it in the comment section down below. Thank you very much for watching, and I will see you in the next video. Ciao, ciao, and goodbye.